Hello everyone, so today I'm going to go over how to calculate z-scores in Excel. I'm looking at the probability distribution of a normal sample distribution itself. There's a couple different ways to do it, so I'm going to have a few examples within the same data set of how to get to a z-score, then look at that probability distribution versus looking at the z-table that you often have to do. So with that, the data set you see in front of you, I went ahead and downloaded Table 8 from the FBI UCR Part 1 Index Crimes. This is for 2018, the most recently available for the FBI, even though it's, September of 2020 right now. So what I've gone ahead and done is this is the original data. With that, I've just copied over the city population of violent crime columns to calculate the violent crime rate per 100,000. Here you can see the formula that I used to do that. I then did descending sorting by the population. So here you can see the highest city population being Los Angeles. And I was only interested in cities with a population over 100,000 that you can see down here. So I copy and pasted those over. And you can see here we have 147 different cities going down to Boca Raton, back up to LA. So with that, I've also copy and pasted the formula for calculating a z-score. Here I'm not using the scientific notation that you might expect to see with a sample mean and the standard deviation of a sample. This I use as an icebreaker when getting into some of my intro classes. So here we have the value of x minus the sample mean over the standard deviation of the sample itself. So we need to calculate the values first for the mean and standard deviation before we can even calculate a z-score or the probability associated with that. So the first part here is calculating the average, the mean itself. So we're going to use that same function. And as a reminder, I'm going to click on the first value, press and hold Control, Shift, and then the down arrow to select all of those values in that column that I need. Close the parentheses off, hit Enter, and I now have my mean value. I'm going to do a similar process for the standard deviation. Hit Enter, and I now have the mean and standard deviation for the 147 cities with a population over 100,000. Keep in mind, looking at the violent crime rate per 100,000 residents, so that's how we're going to interpret this back to cities with a violent crime rate. So we have now our mean and standard deviation, and we have our values that we already calculated with the violent crime rate itself. So we have our value, we have the sample mean, and the sample deviation, standard deviation. So with that, we can now calculate the z-score. The first way we're going to do it is based on this formula itself. The second way is going to be an Excel way to calculate it similarly. And then we'll show the probabilities. So we're not always going back and forth between the table to see the probability of the distribution that's to the left of the z-score, the value that you just looked up and calculated. So with that, with the z-score, we're going to follow the orders of operation here. So I'm going to start with parentheses similar to how I have it here. We're going to start with our value and then subtract the mean from that. Close the parentheses off and then divide by the standard deviation. Now the key part here, if I were to hit Enter, we have our z-score. This is great. We can look up 0.83. If we were to come over here, 0.8, and then at the top find the 0.3, we now have a 0.7967. Sorry about that. So keep in mind the negative versus positive side. We'll look at this as a quick example of when we get some negative values. So here, the issue is if I wanted to copy and paste autofill all this same formula down is it would want to use the mean and standard deviation of the corresponding, that would be E3 and F3. So before we did that, so if I ran it here, there's an issue because it's trying to draw on E3 and F3 and we have nothing there. So an easy way to do this, since we already calculated the mean and standard deviation, is to anchor, pretty much lock those cells in place so it's drawing from those same numbers. And we do that with the $ locking the column and row in place, so we get cell E2. We're going to do the same with F2. So if I do that now, hit Enter and do the same autofill, we now get values all the way down to Boca Raton. And here it shouldn't be too shocking that we see some negative numbers. So we look at their violent crime rate. We know their violent crime rate per 100,000 residents is lower than the mean of 473. So that's why we see a negative z-score here. So that's an easy way to eyeball and double check just at face value, was it done correctly. Another way to calculate the same z-score in Excel is to use the standardized function itself. So type standardize, you can see here, normalized value from a distribution with the mean and standard deviation. So here, once you start the parenthesis, it's asking for your x value. So here it's going to be the 747 again. Similar, the mean and standard deviation. If you close it off, the key part here, if you're wanting to autofill down, is to anchor those or pretty much lock those in place again. So don't forget about your dollar signs. Here, not surprisingly, you get the same value. It's doing the same calculation just in a different way. Here we did it almost a step-by-step based on the formula. Excel had the built-in standardized function for you. So either way, you get the same answer. How you go about it's a little different. However you choose is yours, but those are just two different ways to get the same formula within Excel. Now, traditionally, you would look at each one of these z-scores and then you find it on the corresponding table itself, and then look at the probability distribution that's under the curve to the left of that value. That can become very time consuming. It's not that difficult to then look up the values on the left and right and find where they intersect, but it would also be pretty handy if Excel did this for you as well. With that, there is a way that Excel can do this for you. I'm going to go ahead and pull that up and show you. I put this in here and keep it in here because it is very beneficial to make sense of what's going on. But if we wanted to go ahead and just calculate this z-score probability within the distribution, we can do that in Excel too. So to start off, under this column here, we're going to use the normal sample distribution. So norm.s.distribution. So here it's asking for two different values. It wants a z and then a cumulative, which is the true or false. If you say true to cumulative, it will take that point of the probability distribution and give you everything that's to the left of it. Ideally, that is what you want versus just that point itself. So here we're going to click our z-score, going to do this one, and go ahead and hit comma true. So it's going to be the actual cumulative value. We get 0.7957. Now you'll notice it is a bit off compared to the z table. So if we click back over here and go 0.83, this one is 0.7967. Very close, a bit different calculations. This is just one table that I pulled up through insert online. But if we do that, similarly, you can copy and paste all this down. And this gives us a good indication of the probability of the distribution itself. So if we're looking at LA itself, the top one here. So we know the violent crime rate in Los Angeles is higher than the mean, so we already know that's going to be positive. To the right, we see that in the score itself. And if we just eyeball it with 0.79, so about 79%, the probability of the distribution is going to be to the left. So about 79% of the distribution is to the left of LA when it comes to the violent crime. Now, in the off chance that you did not have the z-score, Excel does give you the ability to still identify the probability of the distribution falling to the left. So we're just going to put probability up here. And here, say we didn't have the z-score, so we're just going to use the normal distribution itself. So if you see here, it's similar, but we need the mean and standard deviation before we identified that we want the cumulative true part that gives you the probability of the distribution to the left, the full amount over there. So similar, we're going to start with LA. We're going to choose our X value. Here it's LA of 747. Our mean, oops, of course I hit the wrong one, E2, comma, the standard deviation, comma, then we want true. And keep in mind, if you're wanting to autofill all the way down, you're going to want to lock in or anchor the mean and standard deviation. So you'll want to put the $ sign for the column and row for both of those. If I hit enter, and I'm going to move this over, we get the same value here. So that's what we were hoping for. That means we entered the formula correctly. So we showed a couple different ways of calculating the z-score through the formula, through the Excel option, then the probability of the distribution that's to the left of that. Keep in mind, if you ever want to identify the probability of the distribution, so that's to the right, greater than that value itself, it would just be 1 minus that. So if I wanted to do to the right, it would be equals 1 minus this value. And you see here that it gives you just about 20% is to the right. So for an example, let's find one of my favorite cities, Little Rock, Arkansas. It tends to be very violent. You can see based on the Z-score itself of 2.93, and then when you glance at the actual violent crime rate per 100,000, it is much greater than the mean itself, potentially even an outlier, but we're not getting into that here. But if we look at that, so now we have the Z-score, and here the probability of the distribution to the left is 99%, 99.8%. So you can see that not too many cities with a population over 100,000 have a violent crime rate that is higher than Little Rock itself. It tends to be that way from year over year, which is bad, but gives me a great study site within that. So this is just an example of using the Z-score and the probability of the distribution, or under the curve for the distribution, in Excel, and how to calculate it with real-world data that I downloaded from the FBI. If there's any questions, please feel free to shoot me an email. Take care.